A.c file, then the read, the open the file. So this is the student.txt file. You can open the student.txt file and read and write the information. Then you can read byte by byte until comma, and read the next one, comma, and next, and the new line is the new student, another student, and so on. You can do the programming. Okay, we can do the exactly same thing using the database. So we can create the database, and the student is here. Later in our programming, we can select name, ID, address from student. You don't have to worry about the query. We will learn later, where the name is the lead. This is a database approach, and this is the without database approach. In other words, we can use the file system. What's the benefit of this approach? Less coding. Less coding means that it's a simple.
No, because here I have to store each student information
Yeah.
separately, like name, ID, and everything
Yes,
separately.
that's a key point. You need to know each and every structure of this one. Okay, whether this is separated by the comma, or whether the name is 10 byte, or whether it's a new line is the new record. You need to know everything about the structure of your source of your data. Okay. Also, if you change, for example, I add the information like the major. You need to change the entire code. However, what about this one?
Only query change.
So even you don't have to change, even though you add one more column like the major, you don't have to change the code. Okay? So that is the one main characteristic of using the database. Is this database has the structure, keep the structure of your data, like the student table has a name, ID, and address. The name is the character, and the ID is the number, and so on. It's a describing nature. Okay. This one does not have such a detailed information. In your application program, you need to know. However, in the database system has a self-describing nature, which means the structure of data are stored at the database. Okay, so you don't have to manage it separately in your application. So application will be simpler, much simpler. Even though, for example, if you change the name of the file, student.txt file to the student1.txt file, you need to change all the code. However, in the database system, I try to move this one to another file system, but as long as the table name is the same thing, you don't have to change. So program and data are independent. It's an abstract. So it provides abstraction if you are using the database system. So it's much more convenient. Okay. By the way, so this one is always better solution. The using database looks like so good.
In case of using large,
For example, when I work for the database administrator, it is true. Not all company have the database administrator. So because it's a very high salary job, so and also it's not easy to find the experienced database administrator. So usually the small medium-sized company, they assign one of the developer as the administrator. So you are going to be in charge of the database and so on. So one time I have a chance to consult one of the small company who are using Oracle database, never been managed, but the system is slow, so I consult the database system. So I log in their database, and first problem, their table name and the column name is like the T1, T2, T3, and so on. Really, like that. Not like this, almost. There's no way to identify which one is which. Even column name is like the COL1, COL2, something like that. So it was really hard to understand. But finally figured it out with the programming. Then later I realized that total size of their database is less than 200 megabytes. Even though they create a lot of the table and so on, so total size is less than 200 megabytes. Then they paid a lot of money. So for example, if you purchase the Oracle database, so not only just the purchasing price, you need to pay the 20 or 30% of the purchasing price every year as the maintenance fee. So like the customer service. So it's just a maintenance fee you need to pay. It's still paid. Nowadays also, if you install the Oracle database instance in the 8-core, 32-core system, they pay by the number of CPU. So even though you are not using a lot, so they said their database is a very important database, but they do not actually fully utilize the functionality of the benefit of the DBMS. Instead, I recommend why don't to use just a file system, okay, to keep the such a consumer data and because they do not change it frequently, such a structure, okay, mostly historical data and several times of the new customer information, okay. At the time, considering the money and the budget, this one is the better solution. So not always the database is so it is true that when you will have a chance to design the new product or the new IT environment, new system, then automatically include the database and the database. But sometimes you don't need it. Sometimes you can combine several database, the instances, the one, okay, the combined one. So not always the database is a good solution, but since the database approach has such a characteristic and the benefit, so we are using the database system. Okay, so there are basic functionality that the database management system provides. Definitely the retrieve modification. These are the same functionality. The basic is the same operation that you learn in your data structure class. You remember the data structure class? Fetch, insert, update, delete. So it's the same thing in the database. Provide exactly same the basic operation. Instead of the fetch, it's called the select, and update, delete, insert. It's the same operation. Okay. So that's the way. So that is a query. We will talk about the later transaction. The database system. Finally, we will have the database system here. Database system is only for the single user? Obviously not. It will be used for many user. So when we allow the multiple transaction, many user, what will be the problem? Deadlock. It's a synchronization issue. Okay, because we have the one shared data, but the many transactions, many users are accessing. So definitely we need to address the problem. So one of the solutions is using the transaction. So we will see how to manage the transaction later. In case the database is a single user system, like the old version of the SQL Server, the Microsoft SQL Server actually started from the single user database system, just like the Windows until the Windows 98. So it is a single user system. Then they throw away the single user system, instead combine with the Windows NT server, which is a multi-user system. So similarly, SQL Server was a single user. Nowadays, by combining transaction module, it's a multi-user system. And then also database provide comparing to the file system, the non-database system, is the security and protection. We are not going to deal with the details of the security, the issue and protection in the database, but it's not very complicated. So if you take the operating system, you can easily understand the security issue in the database. So our goal is to build such a database. from the information. So we'd like to build such a database. So that database, for example, the course has the course name and so on, and plus is a sample data. So when I will explain later. So these are the characteristics of the database that I explained. So self-described nature means the database itself has the information about their data inside as a database format. So for example, the Oracle is called the catalog database, or sometimes in general it's called the metadata. But each and every DBMS has their own such a metadata, the database, catalog database. So for example, MySQL has a schema view like that, so you can search such information. Okay, then the insulation means is a program data independence. So if you remember this, so because we separately manage the data structure of the data. So program doesn't have to worry about the structure of this. Instead, just access the information. So it's a program data independence. Okay, and that is called the data abstraction. So okay. And definitely support the multi-user, multi-view, and the multi-user system. Those are the characteristics of the database. Okay, you don't have to worry about the types of the user. Okay, then so advantage. We already did talk about the advantage of the database. So you can quickly read and understand such a thing. Okay. Let's see, the chapter 1 is done. When not to use, so we already discussed. If the database total data size is small, you don't have to consider the database management system. So database, this is one of the interesting questions. What is the main reason to use a database management system? Main reason. Organize. Why do you want?
It is very important.
Yeah, so that is the common answer. So my data is important. Yeah, all the data are important. So, but to protect your important data, database is not always the best solution. Sometimes it's kind of a security work. So have you ever heard about the SQL injection hacking technique? So what is that?
Within the text entry itself, you try to write a query to fetch.
Yeah, for example, the user, the password, then if you click, there is a search. At the time, if you sometimes asterisk, it will return all the user and password. Okay, it's called the SQL injection, the hacking technique. So like this one, there are a lot of security holes in the database. So if you just consider the importance of the data, the SQL is not, the database is not the best solution. Even though you do better to use your own programming to protect the data. It's my opinion, so it's still controversial. The main reason, main purpose of using database is the speed. Okay. When we have the very large data, the main problem of managing such a very large data is very hard to access the data because it's big. You need to speed up. So if your database is slow, so you don't have to use. Okay, you need to think about the different approach. So since because we need the fast, the efficient accessing the data, we need the database. Okay, so when you consider the types of database, so even the DBMS, each DBMS has the different characteristics. For example, Oracle usually prefer the online transaction. So online transaction processing means fast response time, okay? Like the banking system or stock market system. On the other hand, the Informix or Informix, right now the Informix is part of the database, IBM database, but the Informix is good for data warehousing, it's batch processing. And each one has their own characteristic, but the overall, the goal of the DBMS is to speed up, to search the data. Okay? So that is one of the things you need to consider when you decide whether we need the database or not. Okay? So we already talked about what is the data model and what is the database model. It's a set of, it's a data structure. It's a set of rules. Okay? To standardize the data, we need to define set of the rules. So that is the data model. Okay? Plus, we need to operationalize the select, update, the insert, the delete. So we are going to define such a operation, just like the class. Think about the class. When we define the class, so it has the set of data and set of operation. Similarly, we are going to define. So this is the data model. Okay. Then there are different types of the data model. The first one is a conceptual model. Conceptual model, if you remember first So first, conceptually, we are going to organize the scattered information. It's a conceptual design. That is called the conceptual design. Sometimes it's called the high-level design or the semantic level design. It's not directly related to the computer. It's just conceptually. So domain expert, the work for such a conceptual design. Then the next level is a physical data model. Physical data model is how this data is stored in the database system. It's a physical level, like whether we are going to use the integer or the number or the decimal. In case of integer, how many bytes are allocated? It's a 4 byte, and the double is 8 byte or 2 word, and so on. So such a thing, the detailed, the physical level, the model is the physical data model. So when you search your job, sometimes the job description asks 3 years of the conceptual modeling or high-level modeling, or the 3 years the physical database model, and at that time you should be able to understand what's the meaning of the conceptual level design. There are implementation data model and self-described data model. You don't have to worry about it. This is just the opinion of the author of this textbook, Dr. Emersary. So it's not the general term used in the database. But the conceptual data model and the physical database model, you should be able to understand the different things. So our goal is to build to find the database schema. Database schema means this one, the database model. Output of the database, the model is the database schema. Schema means it's the description. So our goal is to design the database, which means we need a description of our design the database. That is the database schema. So such a database schema includes the name of your table, and the field, the how many field, and number of field, and the type of field, and such a thing. So such a thing will be the design, and usually this schema is represented by the schema diagram. If you take a look at this example, you can easily understand. So this is a schema. So schema is the description. It's a kind of the, so I'd like to build a university database, which means I need to design the university schema. So university schema means that the schema describes the university database. So it's kind of boundary, okay? It's a territory that describes only the university database. This is our goal to the design throughout the semester. So this is one example of the university database schema. It has a student course, prerequisite section, and the grade report. For example, student has a name, student number, class major. It's actually more detailed. It's a very simplified the schema diagram. So anyway, keep in mind our goal is to design such a schema diagram. Okay, so that is a schema diagram. Then not only just to design the database, eventually we need to create a real instance. Like after you design the class in object-oriented concept, you need to instantiate the object, number of objects. Similarly, we need to create the database instances, sample data. So that is called the database state. For example, like this one. So the course has a course name, course number, credit hour, and department is a schema. Plus 1, 2, 3, 4 sample instances. So this is a final goal of our database design. So we need to design the schema, then insert the real data, then it's ready to serve for the user application request. So this is called the database state. At certain time, it's a snapshot of the data. The database is called the database state. So you are going to create the database, a certain database state at the end of the semester. Okay. There's one more important concept I'm going to explain, so which is the three schema architecture. So when we design the database, so when we consider the database, each and every database has the three levels of the schema. The schema means what? It's a description of your data and the database. So that is, one is a conceptual schema. So it's a three level. So it's called the three schema architecture because it has a three level. So this one is the conceptual level. Level schema. And this is the internal level schema, and this is the external level. External level schema. External schema, conceptual schema, internal schema is called the three schema architecture. The reason why the database has the three schema is our goal of designing is to build a conceptual level schema. Okay? Like for example, I'd like to create a student table, and I'd like to create the teacher table, and the course table, and then the student has a blah 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 this the attribute like that. However, when you create later after designing, you'd like to create a student table using, for example, MySQL. Do you know how the MySQL create the table inside? You don't have to know. Okay, it's not my job. That's the reason I suggest the MySQL. Okay, so inside the internal, there might be schema, physical low-level schema, how to create the student as a file. Okay, student file. This file has the block, a number of block. Each block has the how many bytes for the name and ID, but you don't have to worry about internal schema. Instead, the DBMS, database management system, in charge of that. So they are separated. So, however, if you are using the file system, you need to consider internally how to store the data. You need to take care of everything. But because program and data are separated to support, actually this idea comes from these three schema architecture. Okay, internal schema and the conceptual level schema are separated. Okay, then the level of the schema is external level schema. For example, think about the student information. So I moved in the new apartment. So you need to inform to the IRS if you are international student. And also you need to inform to the HR, you need to inform to the registrar office, that it will be complicated. If the database, your student, the database is in one system, you can just change, okay? Then the HR can view the student information, okay? What they need is just the social security number and the name and profile. But the payroll office need to know your social security number and your account information. And the department would like to see the GPA and student profile. So if you create each and every different the user for your student account, it will be complicated. So instead, we are going to have the only one conceptual schema for the table, okay, for the information. Then it can be viewed differently. Physically, it's one, but virtually it can be viewed as differently. So this is called the external schema, external level schema. So all the database management system support these three schema architecture. Okay, what we are interested in is the conceptual level schema design. Okay, instead, this internal level schema will be managed by DBMS. That's the reason we purchased the software, the database management system, use it. Okay, because they understand the conceptual level schema, the relational model, so we can use the same database model. However, later when you are using any DBMS system, if you understand this one, then it will be much easier and much better performance you can get. So if you know where the data, your table is located, if you do not know, sometimes you cannot address the problem. So later, after we finish the database design part, we will talk about a little bit inside the internal schema also. But the problem is each and every DBMS has their own the internal schema. Okay, it's not standardized, but this part is standardized. Also, external schema is very simple in the relational database. Later, we will talk about the view. So using the view, we can simply implement the external schema. So this three schema architecture is the standard. It's an ANSI standard. So which means if you develop the new database model, okay, ABC database model, that supports basically conceptual schema and the internal schema and the external schema. So this is a three schema architecture used in most of the database system. So internal schema, and this is the internal level how the data are stored. So the conceptual schema that we are interested in to design. And the external view is the external schema is simply later implemented by the view. This is not the real the schema. It's just the view, different view of the conceptual schema. This is called the three schema architecture. Then the problem is that they are different level of the schema. So we need to map between this one and this one. So this external schema and the conceptual schema using the view concept later in SQL we can create it. The conceptual schema and the internal schema DBMS is actually the address, the map, such a problem. Then finally we can keep something logical data independence and the physical data independence means, for example, if we move the data, student data is the first time here, but the DBMS realized it's full of the data. So we migrate to the same data into another storage, but it doesn't matter from the conceptual view. We don't have to change it. the conceptual view. It's the independence, okay? The physical independence. And also same thing. So I add one more column for the student table. But from the view, you don't have to change the external view. Unless this one need a new one, otherwise you don't have to change. It's it's called the logical, the data independence, and also physical data independence. We can keep the abstraction level of the data using that. Okay? Almost done. Then database also provide the language, okay? Which is called some of the students believe the main reason to take this class is to learn the SQL. So that is true, but the SQL is the part of the SQL. You realize it's just a part of the DBMS. So it's to create, to select, to implement. So do you remember the one part of the data model is the operation? So how can we implement the operation? So using the SQL, structured query language. So there are different types of language, but basically two. One is the data definition language, another one is data manipulation language. So data definition language is to create the data structure, like create the table, create the object, create the something, okay, or remove such a data structure. So that is a data definition language. And another part is the data manipulation language to handle the data. After you create it, insert and update the delete, so it's a data manipulation language. Both of them are considered as the SQL. There is another one, it's called the data control language, like the permission. Like the grant or the revoke the permission. So data control language is somebody considered as a part of the SQL, but it's not very difficult concept, so you can easily catch up. So many data, we will learn both of them, data definition language, data manipulation language, while we are talking about the SQL later. Okay? However, the main difference between the SQL and the other program language is the SQL is, as the name implies, it's a structured query language. This is the query language only for the relational database structure. Okay, it's not general program language. Unlike the other procedural languages, it's only for this database structure language. It's dedicated. However, because it's very popular and very easy and very strong, many of the applications use the similar, the SQL-like the query language. You can see the name of OQL or the SQL or the something QL, the Spark QL and so on. So, but it's the name actually from the structured query language. So, okay. I'm going to skip this part. We will discuss the database program language after we finish the SQL. Probably after the midterm or before the midterm exam, we will see. Okay. Okay. This is then this slide shows the more details about the database, the management system that I introduced here. Database